Hi guys, Glader here, and today I have an update video about PSOBB2 and VRGuardians. It's going to be a bit of a technical video. We'll be talking about Akka.net, and its now complete integration into GladMMO, which powers VRGuardians and PSOBB2. So if you're not interested in technicals, maybe this video is not for you, but I'm going to go ahead and show you how I've implemented an existing feature in VRGuardians using the Akka actor model, and I'm going to show you it working in game as well. So I've implemented avatar pedestals in this actor model, and if you're curious what actors look like in VRGuardians, we can take a look at one real quick. For example, here is a game object actor. They just inherit from a base actor. They defined a state type generically, and they define, well, themselves. It's interesting design there, but trust me, it's important. So that's pretty much it. And you might say, hey, how can this possibly do anything? Well, the way that you actually add behavior to these actors is through messaging. So to allow for players to send packets on an unspecified thread in an attempt to interact with the world, which is either simulating on the main thread or potentially on any other thread as well, because, why not? So how do you make those safe? Things are going in and out of existence, memories being cleaned up. How can we make this safe? So actors are the answer, and the messaging model is what makes the actors thread safe to interact with, and I'm going to go ahead and show you why. So I'm going to show you a little bit about the networking. I almost never show this, but here is the network message or packet handler for client interaction requests. It's a little weird looking, but basically we just have a reference to actors that are added by GUID. And when we receive the message down here, which just contains the target GUID, all we do is attempt to locate the actor that we're attempting to interact with, and also the player actor, and then we just send a message called interact with entity actor message along with the GUID. And then that's where the actor system kicks in. So let me go ahead and show you where that's going to end up. So that's going to actually end up in this handler right here, this message handler, which, by the way, easy to create, and all you have to do is add this attribute at the top, and it's automatically discovered. You don't have to register these anywhere. It's so nice. So basically, when we receive an actor message, we specified that we want to receive, oh, this is the wrong one. It's under game objects. Here's the right one. So we just say, hey, we want avatar pedestals to have this message handling capability, and as long as the avatar pedestals also have this state type, which they do, then the messages will end up here. Otherwise, they'll be unhandled, and that's okay too. That can happen. So ignore this part down here. That's a little confusing, but the bulk of the operation is happening right here. We check if they're player, normal, some normal stuff, and basically we just say, hey, let's grab our behavior data, which is the avatar model ID, and let's send a change entity actor display model message. So that's just going to send it to whoever sent this to us, because, what do we know? I mean, as far as we know, this is okay. So we just send it back, and no matter what's clicking on us, well, I mean, only players right now, I assume. So if a player clicks on it, good. Now down here we have some a little hack to do asynchronous operations inside of an actor message. Basically, I'm just telling the server, hey, this guy clicked on the pedestal. What's the result? If the result is the same model ID as what the pedestal is, we're good to go. But otherwise, the server can authoritatively correct that. But up here we do some prediction in the odd case. It's not so obvious as movement prediction, but we're doing some predictions so that we can have lower latency avatar pedestals and just correct if something's wrong. So great, that's the message. But what happens with this message? And if you want to see what handles it, you just find the references. If Visual Studio is working correctly, it's not right now though. But you're going to end up over here. So we say, hey, we want players to have this handler for this message type, and all we do is we access the low-level API for entity data. I'm working on a higher-level API so that it doesn't look like we're writing something in C or something, because that's what this looks like to me. But anyway, you just set the field display, and this data blob of binary that backs this is actually delta compress replicated to the client, and so we're good to go. So that's pretty much it. So now we've been able to receive the player interaction on any thread, doesn't matter, and then we can send a message to the avatar pedestal on any thread, doesn't matter what thread it's handled on, and then the avatar pedestal can send its results back to the player actor on any thread. It doesn't matter what thread that's handled on, and then it's good too. And then eventually this data is going to be replicated back to the client correctly. And let me show you that this works. So this actor model is going to be critical for supporting thread-safe interactions between entities. Obviously, the goal in 2019 is to run as many threads as possible, or cores rather, on your machine, so you can actually, that's great, but you need to utilize them. And you can't utilize them with many approaches without significant overhead and locking and complexity. This boils it down simply. We just message each other. Lockless, concurrent. So it's going to be big. It's going to be huge for like worlds with 100 players, 200 players, with 1,000 objects in them. It's going to be big. It's going to be important. So here we are. Let's pick one that currently is a different model. Okay, sweet. So one thing that we broke was avatar pedestal rendering on the client. I'll fix that eventually. But you see if we actually interact with the pedestal. Look, we changed the avatar. So it's all working. This migration to the Akka model is working. It's complete integration. It's it's very user-friendly, actually. You don't have to know much. You just need to know, create a message, create a handler. Pretty much good to go. And if you want to send a message, you need the actor ref. That's pretty much it. And so that's how a lot of functionality going forward is going to be implemented. Especially functionality that involves multiple entities. It's the only way to do it safely. So that was the video today, guys. A pretty technical video, but if any of you were ever interested in it, that's how we're doing it. And going forward, and it's going to be big. I can't describe to you the potential behind this right now, but maybe one day I'll show you. Thanks for watching, guys. See you in the next video.